Good afternoon, everyone, and thank you for joining me today at Lincoln Agritech Beyond Number 8 webinar session. I'm Joanna Lee, Marketing and Events Coordinator at Lincoln Agritech. I'm responsible for events organizations and coordination, as well as working with my manager Ashley to look after Lincoln Agritech general marketing staff. So our Beyond Number 8 series aims at sharing agri-tech knowledge and insights for our primary sector. We launched it in 2022 as a series of a podcast, and now we extended to including webinars. I paste the podcast link in the chat box later, and so feel free to listen to them. Welcome back to our previous viewers, and a very welcome to you if you tuning in for the first time. It's great to have you on board. Today we were privileged to be joined by Jaco Fourie, machine vision principal scientist here at Lincoln Agritech, to shine some lights on data science. He has extensive experience in image processing, computer vision, machine learning, and data science. We will share some knowledge, experience, tips, and insights with you. The session is planned for 40 minutes, including questions at the end of it, about 10 to 15 minutes. We are recording the webinars, and your cameras and microphones are disabled as default, but the Q&A is running live via chat box on top of your screen. So feel free to leave your questions as they come to mind, or you can ask Jaco after his presentations. I believe he will answer you very well. Right, I'm now going to ask Jaco to give a brief intro and start today's talk. Let's welcome Jaco.
Right, thank you for that introduction. I'll get my presentation up now. Let's see. Okay, hopefully everyone sees that now. As you mentioned, I'm Jaco. I am the... Oh, my presentation's not moving forward. One moment. Here we go. Okay, great. So yeah, I'm the principal scientist in the machine vision group at Lincoln Agritech, as was mentioned. My background is mainly in image processing and machine vision. But like almost all the scientists, we had to adapt to AI changing the way we work. In our case, this was the field of machine vision, and it was completely changed by AI a few years ago. And so back in 2015, 2016, we had to adapt and all become AI experts. So our team has undergone a lot of training and practical knowledge since then. And we're now at a point where we regularly develop our own custom models, and we publish novel contributions to the field of machine learning and AI in top journals. And then more recently, we also started moving into this more specialized subset of machine learning called data science. And we took some courses to fill our knowledge gaps in this area. And so today I've been asked to present on data science, and I'm going to structure my talk as follows. So first, we need to answer what is data science before we can really talk about it any further, define it properly. And then I will talk about what do you need to take advantage of data science and the nuts and bolts around what you need to get started. And I'll move on to specifically what can data science do for agriculture and some small case studies there. And I'll end the talk with a short demo on what it may look like if a client comes to us with a problem and how we would then use data science to build a small dashboard to meet the needs of that client. So what is data science? In my opinion, I think the best way to answer the question of what is data science is to focus on the why and the where. Why has it suddenly become so important, and why is everyone trying to integrate it into their business? Because the term data science itself, just like AI and machine learning and many others, is jargon. It's become one of those terms that journalists grabbed and they just use it wherever it feels like they can make money out of it. And it's very difficult to find a single definition for it because of that. I say broadly it refers to the technology of extracting actionable insights and value from data sets, usually very large data sets. That definition doesn't really sound like anything new, though, and actually it isn't. Processing of data and extraction of these valuable insights is as old as data sets themselves. And so what is driving this new interest? And in my opinion, it is actually the amount of data that we currently have to deal with. The amount has exploded. It's incredible. We're at a stage now where you can see from this diagram, which is published by an organization called Domo, and they update it every year. And this shows how much data is being generated every minute by various companies and sources. You can see, for example, YouTube has to deal with 500 hours of video every minute. Facebook deals with 1.7 million pieces of content and stories every minute, and various other examples. And by the way, this diagram is from 2023. It grows every year. So the amount of data and the value of that data is, I think, what changed the game here. There's an incredible amount of value locked up in this data set. And the problem is, how do you extract this? And I think that's what data science is all about. So my opinion, to summarize, data science is what makes sense of the chaos and extracts actionable insights and gets to the value of the data. I should also mention that we're at the point where data science is definitely no longer just a trend. It's been getting more and more important to the point now where it's just about critical. As seen from the previous diagram, we're all generating, all industries and all businesses are generating these massive amounts of data. And for a company or an industry to be competitive and have a competitive advantage, the business decision making now has to be data driven. And because of that, AI and machine learning has now become mainstream. It's just another tool. It's not even really a specialization so much anymore. But it relies on these large data sets. You need to know how to deal with these large data sets to actually make use of machine learning and AI. And this demand is driving an industry, and according to Hayes New Zealand, that collects this data every year, the demand for data science skills is up 11% every year since 2019. And because of that, New Zealand industries are now paying between 120 to 180,000 per annum for data scientists as a skill. And there's actually a large knowledge gap here. There's not many data scientists, and so a lot of this is also being driven by scarcity. But what can you do with data science? This is answering the what. Where does this value come from? The amount of and diversity of the data that we typically deal with makes it impossible for a human to keep all the aspects of the data in their mind at once. And so potential insights from this data set are often completely missed. So one of the main contributions of data science is that it discovers insights from raw data, even the ones you don't even realize are in your data set. And then the question is, okay, well, what do you do with these insights? What can you potentially gain from these insights from your data? Well, mainly better decision making, often more efficient workflows, and sometimes you even get completely new revenue streams. And I will mention two famous case studies later in the talk. But generically, the common examples come from, firstly, healthcare. They've got a more established use for data science already in the form of personalized patient care based on medical history and genetic data. Medical history can already be a very large data set, but genetic data is absolutely enormous, much larger than can easily be handled using traditional data processing needs. And so data science is what really makes this possible. In manufacturing, they've already got quite successful in predicting equipment failures and optimizing production schedules in factories. And that's because you can now fill your factory with sensors, and sensors that feed large data sets directly, which can then be processed using various data science techniques. In retail, this has also been used extensively for many years. in upselling and cross-selling products, specifically by analyzing customer behavior and customer purchase patterns. And later on, as I mentioned, I will give some agriculture-specific examples, but these are just some well-known examples from other industries. So we move on to the second part of the talk now, and I'll focus on how you can take advantage of data science and what you need before you can start. So firstly, data quality is everything. Most of data science happens long before AI and long before models, and it involves cleaning and pre-processing of the data. And this ensures that the data that actually gets to the AI model is in a format that the model can understand and efficiently extract patterns from. The quality of the data is important because dirty data leads to dirty insights. Data scientists, as I mentioned, spend most of the time cleaning and filtering data sets. That's the main part of data science, actually. Bad or incomplete data is a big problem. It's like a detective trying to make sense of a case, but all the witnesses have conflicting stories and all the evidence is contradictory. So we spend a lot of time just dealing with the data set even before the modeling starts. Equally important is quantity, though. More data quality allows for more complex models and more robust conclusions. If you have a small data set, then you're limited in your accuracy. And depending on what model you use, this could even lead to overfitting of the model. When you overfit a model, what you're doing is you're training the model on a data set that's too small to the point where the model actually memorizes the data set. And this is very bad because it looks like the model is performing really well. It looks like the model is getting perfect accuracy, but it's specific to the training set, specific to the data you've already given it and you already know about. And it becomes useless at predicting anything new. So when it sees a new data point, when it sees information it has not been trained on, it becomes completely useless. And so it's not generic. It doesn't generalize to the real life. And it becomes useless. But it's dangerous because during development, during training, it looks like it's doing a really good job. So that's the danger of having a limited data set or a data set that doesn't cover all the possibilities. So in conclusion, you need to aim for clean, accurate, and relevant data. And you have to ensure that you have enough data to train robust models and draw meaningful conclusions. I really should also mention this term big data because it gets used a lot when people talk about data science. Like, when do you have big data? This is another one of those terms thrown around by journalists, and it's even more difficult to define within data science. So I would again say, broadly speaking, big data refers to data sets that are so large that they're large enough that traditional data processing techniques are no longer appropriate. It's no longer practical. And I will hopefully explain what I mean by traditional data processing and how that differs. But when you talk about big data, they always refer to the 5 V's that characterize big data. The first one is velocity. It's the speed at which your data grows and the speed at which it should be processed. So, for example, if you have a field full of moisture sensors or a factory full of temperature sensors, they're all going to take a reading at a regular interval, maybe a few times an hour, and all of them are going to combine and get fit into a single data set. And so that data set's going to grow every hour or every minute by some amount. And if it grows very quickly, that's one of the attributes of big data. It becomes more difficult to process, becomes more critical to process it quickly. The models need to be updated, etc. So velocity is the first view. The second V is volume. That's a bit more of an obvious one. It's just the amount of data. When your data set grows to a size, when you start talking about terabytes and even petabytes, you can start talking about big data. Value is another one. Value refers to, well, the value of your data set. Many organizations have come to the realization that their most valuable asset is actually their data set. And when that becomes the most valuable part of your business, it becomes more and more important to secure it. It needs to be stored in a redundant way so that it's safe. You don't want to lose it. You don't want it to be stolen. You want it to be encrypted. You want to control access. All of that adds complexity. The fourth V is variety. That's just the diversity that exists in the type of data. If your data set consists of information from a single sensor, if it's a single modality or a single kind of format, it's relatively easy to process. It's relatively easy to store and secure. When you start adding lots of different kinds of sensors, if you've got image data and video data and sensor data, historical data combined with live data, that adds lots of complexity and is one of the defining features of big data. And then the last V is veracity, which is the quality of the data. I've already mentioned how important quality is, but in data sets that are large, high value, they grow very quickly, the veracity just becomes more important. The quality and the control of that quality and how you practically do that in real time is one of the features of big data. How does this actually change the way you process and analyze your data set? Because I mentioned that big data is when you get to a data set that's too large or too complex that you can't use traditional means anymore. So what are those differences? Well, when it comes to velocity, the first V, if you're going to update your data set in real time, if your data set grows really quickly, it means you have to process it really quickly. And it also means your model needs to be updated in real time. That requires specialized processes, specialized hardware even. It becomes much more difficult than you would in a normal data processing pipeline. Volume is a more obvious one. Large data sets require specialized hardware. You can't just save your data set on your hard drive, on your PC, and you can't just load up your data set into memory when you want to process it or analyze it. It becomes so large that you need specialized ways of storing it, specialized ways of accessing it, and processing it as well. And that requires specialized hardware. Value, well, as I mentioned, if the data set is very valuable, then you can't just store it anywhere on any networked server. You need to take great care to secure it. You need to take great care on monitoring who has access. IT becomes much more important. Managing of your asset becomes a real value proposition. So that's different as well. As I mentioned, diverse data sources and data formats generate lots of extra complexity, which means you need to write probably some custom software for it, which then needs to be maintained and updated, adding to the complexity of your problem. And veracity, as I mentioned, quality control becomes a big deal in these big data sets that are diverse, that grow quickly, and it also becomes much more difficult to do practically. If it's a small data set, if it's a simple data set, one person can sit there and know what's coming in and what's going out. And even automation becomes simpler. But if it's a very large data set that grows very quickly, that has lots of diversity in it, then quality control becomes much more difficult, but also much more important. So because of this, it's often better to outsource these responsibilities to a specialized service provider. However, as a caveat, depending on how sensitive your data set is, privacy concerns might actually mean that you do need to hire someone and have them sign a contract and keep them in-house, which again is why there is this great demand for data scientists, why it's so difficult sometimes to hire them. Now, I'm going to relatively quickly go through two case studies, just because every time anyone gives a talk on data science, this gets mentioned as the great success stories of data science. The first one is Amazon. Everyone knows Amazon and their recommendation engine. When you go to Amazon's website, when you buy anything, when you go to any of their product pages, you'll always see other products being advertised to you. And the choice of which products get advertised to you and which sales get targeted to you, that's all due to Amazon's recommendation engine. They suck up data from your behavior based on your internet cookies, based on your purchase behavior, your search queries, and lots of other things. They will track you across different websites, and they combine all of this information into a giant database, which they then analyze and use to predict the most likely next purchases and predict which products you would be most likely to purchase next. And according to McKinsey and Company, up to 35% of Amazon sales come directly from their recommendation engine. In a large company like Amazon, you can imagine that 35% of sales is an incredible amount of money, which makes this an incredibly valuable algorithm. It's a prime example of how Amazon used data science to boost their sales and improve customer experience. As a next example, which is quite similar, is Netflix. Similarly, they also get a lot of user behavior data that they analyze and pull into a data set and extract, and they use this to curate a personalized viewing experience for their customers. And they also use lots and lots of different factors that they combine into a single data set, which includes the viewing history, ratings, watch lists, search queries, social media interactions, and demographic data. They spend a lot of time also researching new and better ways of natural language processing, NLP, which actually reads things like your reviews, your comments on Facebook, and analyzes personal likes and dislikes to personalize your front page when you log on to Netflix. But what makes Netflix a bit different, though, is not only do they use this data set to improve their sales and their customer experience, but they actually manage to take the same data set and derive from it a completely new revenue stream, because they also invest heavily in original content. They make their own shows now, and they base the content of these new shows on that same data set that they use for the personalization of your Netflix front page. So it's almost getting to the point where they are making shows based on your preferences. It's custom shows for their clients. It's not quite personalized to the individual yet, but it's probably heading in that direction. So I'll move on to specific examples in agriculture, because a lot of our business is focused on agriculture. And also some of the ways that data science is already being used to maximize productivity and sales in agriculture. And likely the first field in agriculture that saw the value of data science is precision agriculture. Yield prediction is likely the easiest application for data science, because you've got lots of data sources that can be combined to form a diverse and large data set that can be used to predict final harvest yield from. These sensors can be both proximal or remote. They can be things like images from satellites, images from drones. You can also get soil moisture sensors, temperature sensors, combined with historical yield data, weather patterns, climate patterns, soil composition. There's lots of potential data sources, and they can all be combined into a data set that can be fed to a model to predict yield. And predicting a single value like yield is a relatively easy application for data science and machine learning. Then you've got disease and pest control. Many disease and pest infestations, they only become apparent when the infestation is already too advanced to effectively mitigate. And so the goal of data science in this application is to predict when the infestation is likely to occur or is about to occur, based on patterns that you can read from proxies like temperature, humidity, vegetation indices, things like NDVI. And these sensor readings can be identified as early drivers of disease or pest infestation. And if you can successfully predict when you're about to get an infestation, or when an infestation has only recently started, you can do targeted intervention, which would minimize any potential crop damage, minimize the amount of pesticide you need, and potentially also the environmental impact that that would have. Irrigation management is another common application where they use soil moisture sensors spread throughout a field, as well as weather data and climate data, and that gets fed into a model that then creates an optimal irrigation schedule, which would optimize water usage and minimize runoff as well, so that that's also good for the minimization of the environmental impact. In livestock management, you see this mainly from two sides. On the one hand, you can monitor the animal health directly with sensors, which you can attach to the animal, or sensors that the animal interacts with, like scales that they walk over, or gates that they walk through that count them, or measure height and width and fat depth and things like that. So these sensors attached to the animals, they collect data on vital signs and activity levels and feeding patterns. And these patterns can then be analyzed by a model. And if there are any significant deviations from this pattern, it could indicate potential health issues, which again then allows for targeted early detection and treatment, which improves the animal health and the farmer's productivity. From the other end, you can also use the animal's breed, age, weight, and genetic data, other kinds of known data from the animal to generate personalized nutrition, which would then, you can create this customized feed plan, which will optimize the growth and the production of the farm. Similarly, by analyzing genetic data, again, genetic data is a very large data set, which is traditionally very difficult to analyze. Data scientists can use this to create models to help breeders to select animals with specific desired traits, again, leading to improved health and productivity. Another common application, which is very mature and often used also in other industries, is just market analysis and process optimization. Like other industries in agriculture, you can use historical weather and climate data and crop prices to predict market trends. You can predict future crop prices and base your business decisions on that. Similarly, demand forecasting. The data on consumer preferences and buying trends can be used to forecast demand for specific crops or agricultural products, and then the farmers can adjust their production plans to meet the market needs and reduce waste in storage, for example. So I'm going to end my talk with a small demo, as I mentioned previously. The demo was initially intended for a much more technical talk, but I will skip over the technical details. And really, it's just an example of what the interaction between us and a potential client could look like when we do, for example, work on a small data set and just extract basic insights and build a small dashboard. So I'm going to stop sharing this screen, and what I'll do is I'll just share another one. Can find the right one. Okay. Hopefully you can now see my web browser and some code. This is an example. It's a toy example. It's not a real client. It's a toy example where, say, a client comes to us with a small data set. In this case, I'm using a public data set from Statistics New Zealand. And the data set actually represents the GDP of the various regions for various sectors from 2020 to from 2000 to 2021. And so we would get our data set initially and download it. We would first just explore what we've got. And I don't know if you can see my cursor moving around. I hope so. And we can see that this is a small data set. It's got only 9,636 rows. And the columns are also very simple. It really only shows the region, the sector, and then the actual GDP amount. So what we do is we say, what can we learn from this as a first attempt? And so we go to the client, we make a small graph, we say, this is the average GDP over all regions and all sectors from the year 2000 to the year 2021. And the client tells us, okay, this is interesting. It's not unexpected, but I have not actually seen any new insights or learned anything new from this visualization of my data set. What else can you tell me? What about the regions, specific regions and the specific sectors? And so what we would do is we would go back and we would make a new graph or something similar. And we would say, okay, here we have a much more complex graph. We now see all the regions color-coded. And on the x-axis, we have all the sectors. And this shows a much more complete picture of what it is all about. However, it's very messy and very busy, and it's not very readable. And when we show this to the client, we get exactly that feedback. So we say, okay, this is not a very useful way of presenting our data set either. Let's make it a little bit more like a dashboard. And we present a graph that looks a bit like this. So now we still see the sectors on the x-axis, the various sectors and the various regions is color-coded. But now we tell our client, well, now you can actually interact with your graph. You can zoom in on it. Not only can you zoom in on it, you can now see the sectors individually, and you can hover over the various parts of the graph, and it'll actually give you exact values as a little overlay. And we show this to our client, and the client comes back to us and says, well, yes, this is interesting. It does show more information. We can now start extracting some insights, but the graph is still very messy. It's still not easy to navigate and easy to really, at a glance, see what it is all about. So can you go back and try something a bit more intuitive? So we go back, we make this dashboard, which now includes a drop-down box for choosing the various sectors. For example, you click on the food and beverage services, and now you see the GDP for all the regions. You can still zoom in on different regions. You can still zoom in on parts of this graph, but now you might not even need to because it actually is much, much more clear. And this is the kind of process which you can iterate over. This visualization of the data set still does not include all the different insights you can gain from it. For example, we haven't actually shown what happens if you filter by specific regions and show all the sectors. We've only really looked at average GDPs. We haven't looked at anything else yet. So also, this graph is still very simple. We could include multiple different views of the same data on different graphs. We can start doing things like integrating it into their website, adding logos and changing the colors to fit the company's color scheme. There's lots of things you can still do with this as a dashboard. We can take this and host it on the client's website or put it in a format that their clients can easily access, turn it into a report. There's lots of ways we can improve on this, but I think I'll leave it here just as an example of what the flow between us and a potential client would look like. And I will go back to my presentation. How would this work now? Stop sharing there. That brings me to the end of the presentation. So I will thank you for your attention. And now I'm available to answer any questions. I'm not
Wonderful.
sure.
Thank you, Jaco. That was fantastic. Are
Thank
there
you.
any questions? Please feel free to ask questions and remember to turn on your microphones.
Well, that's very good. I must have answered all the questions already.
I just I saw people is typing in the chat box.
Okay,
Yeah, here's a question coming from Alice. Would you be willing to provide a link to the notebook example?
sure. Yep, that's not a problem. Nothing in there is commercially sensitive. Like I said, it uses a public data set. So yeah, no problem there. What I'll do actually is can I post it in that same box, Joanna? Does that work?
Which box? The chat box?
The chat
Or
box, yeah. Maybe I can
yeah, it's
just
on.
share a link now.
Yeah, I think so. I'm just share a podcast links as well. Yeah, here's I pasted the podcast. Yeah, sure. I saw the links coming,
Okay, great.
and I actually has some questions regarding that because I know that that has been a trend recently, and they penetrated into our lives everywhere. Like you said, every time when I browsing something online and I got the ads of social media feeds, you know, every time. It's quite a especially after the chat GPT or all the AI tools launched recently. So for those AI tools, how could it impact the data science? Do you have any thoughts and opinions?
The generative AI like ChatGPT certainly having an effect on many industries and all kinds of businesses. I wouldn't be surprised if it changes the way that data science is done. Exactly how it's going to change it, I'm not sure. I guess with generative AI, you could start generating data for your data set synthetically. I know that in some sciences, generative AI is used to generate synthetic data for training AI models.
Yeah.
And yeah, that's quite interesting because if your synthetic data does not match reality very closely, you can very easily train a model that looks really good but performs in a biased way or an inaccurate way. So
Hmm.
I think people have to be careful about how they're going to use generative AI
Yeah.
to get real results.
That's actually linked to my other question. Because how could because I sometimes it's involved in some ethic issues when collecting data or using data as privacy or such things. So what ethical issues should a data scientist be aware of?
Yeah, privacy is a big concern. And I think the most important thing is when you start collecting your data set and when you start pre-processing your data set, you should be very aware of who owns the data, who has control of the data, what data could potentially be sensitive. Ask all the right questions. When you deal with the client and work with other people's data, especially, just be very aware of who owns the data and what the data could potentially be used for and where the data could potentially be abused. I think, yeah, just awareness would be very important.
Thank you very much. And another question comes from Dane. How much data is enough to get meaningful insights? How could you define it? Enough.
Yeah, I was really hoping somebody wouldn't ask that question. That's a really hard one. Because what happens in practice is you take the largest data set you can find and you hope it's large enough. And the rule of thumb is just the bigger the better. So how large is large enough? Well, it it depends on the complexity of the data set. It depends on the complexity of the problem you're trying to solve and how much accuracy you need.
Mhm.
Yeah, it's really hard to it's a bit of a how long is a piece of string question. How large is large enough? Well, when you cover all of the possible things that could happen in your data set. Any example that's not in your training set is not going to be trained for by the model. And so anything that's look similar to that bit of data that you're missing will not be handled correctly in production.
Yeah.
That's how you should be thinking when you decide how large is large enough.
Okay. Is there any other questions? I think we are almost running out of time. Last questions if there's still have people still have questions. If not, then it's almost the end of today's webinar. And a big thank you to Jaco for such an insightful presentation, and to all of you for joining us today. We hope you found it valuable. So if you have any questions and thoughts, or would like to get in touch after today's webinar, feel free to contact us via our website or social media or LinkedIn and Facebook. We would love to hear from you. Our next webinar is coming in the next couple of weeks. So just keep following our social media for further information. Thanks again, everyone. Have a good day. And we were looking forward to seeing you again at our next webinar.
Thanks.
Bye-bye.
Bye.